Hi, it's product review time. Well, it was going to be mailbag time actually, because I've had this one sitting in the mailbag for quite some time, as you may have seen. It's from Saleae Logic. It's their 8-channel Logic Analyser, and well, I know a lot of people want to see this thing, so I thought rather than just slip it into a mailbag, I'll do a full review. So let's crack the thing open, see what it is. $150 8-channel Logic Analyser. Very affordable, and by all accounts, it's got a fairly good reputation, so let's see if it's any good. And here's the case, and ooh, isn't it a bit wanky? Look, nice embossing there. They've spent a little bit on the case there. Well, you don't have to spend much to get that these days from China, do you? But anyway, ooh, look at this. Lovely, nice little... Well, I don't think it's padded, but it's one of those hard shell cases. Really quite neat. Zipper cases. Let's bump the camera there. Let's whip this thing open. And geez, where is it? It's down in there. It's tiny. Look at the size of the thing. Unbelievably tiny. We've got little care package of connectors here. Little micro grabbers, as you'd expect. There's a little 0.1 inch header cable and a USB cable. And that's it. No CD, no software. Doesn't matter. Download it. Save a disk. And check it out. It really is tiny. About 43 millimeters square and not very thick at all. You could fit that in your fob pocket. Not a problem whatsoever. Well, you'd have to curl up the probes and, you know, they'd be a bit pointy, but gee, I don't know. It's a nice little rugged machined aluminium and black anodized case. Very nice. You could probably run over that thing in your car. I'm trying to give that a bit of a twist on there, but geez, that's pretty rugged. I don't think surviving is going to be, ruggedness is going to be an issue for this thing. So there's a little mini B connector. Why are they using mini B? Why don't they go micro USB? I don't know. Anyway, look, they've got that machined into there, pin 1 on the standard 0.1 inch header connector interface, and the ground over there. So you've got your 8 channels plus ground. Count the pins. It should be 9. And I see 4 screws on there. You know what we say here on the EEVblog? Don't turn it on, take it apart. Now this has got little T5 Torx screws on there. I'm assuming that it goes into a little machined and tapped metal post in there. That's what I'm assuming. And I don't expect a lot of logic in this. In fact, I'd be surprised if it's more than like 3 chips probably. One for the USB micro for the USB interface, maybe a little logic device for the input buffer. I'm not sure how much buffering this thing actually does, and maybe the input buffer chip, and maybe that is all she wrote. It wouldn't surprise me if it's even less than that. So let's crack this thing open. Oh, we've been mooned. There we go. There's the back arse of the board, and that should just pop out. Look at that. 1 chip plus a couple of miscellaneous and a reg. And there's the case, machined aluminium, as I said, anodized, and the top is actually plastic. It's you know, there it is. It bends. It's not metal at all, but that's not a problem. You still could run over this thing in the car, and the board would be fully protected. And of course, yes, threaded inserts there. Nice. And of course, this thing is absolutely bare bones as far as the logic analyzer is concerned. We've just got the single microcontroller here, which we'll take a look at. The 8 inputs, which go straight in through 510 ohm series resistors here. We've got some input diode clamping. They'd be low capacitive input diode clamps. So there is some input protection there for overloads and stuff like that. But basically, there is no input buffer chip, no input latch chip, so it goes directly into the microcontroller. And of course, it's got effectively no sample memory in it. It samples in real time on the PC, so it's effectively got an infinite sample memory. The sample rate just depends on the latency of your USB port. They claim the maximum is 24 meg samples per second on this thing, but you've got to have a very low latency USB port to get that full transfer. And well, you know, that is adequate for most uses, you know, SPI, I2C, and other sort of, you know, serial interface stuff. But, you know, this is not a serious, you know, a professional end logic analyzer, not by any means. And by virtue of the lack of an input latch, this thing is effectively timing analysis only. It doesn't do state analysis mode unless one of these pins here can be used as an external clock input and it can actually latch the data inside. I doubt it, so you've got timing analysis only. But once again, for $150 general purpose, you know, low-end logic analyzer, that's all you need. And I don't see any pull-ups as well. There could be some internal to the chip, just those dodgy internal pull-ups on the chip. But they also claim that as far as crosstalk on the channels goes, if you leave an input channel floating, then it may actually pick up crosstalk from the other switching-driven channels. So that's a bit of a worry, but you know, in the end, it doesn't matter, because if you know you're not using channels 4, 5, and 6, you just switch them off in software. And the input logic thresholds on this thing are, of course, fixed, because there's no external circuitry to set your logic threshold. So in this case, it's only got one set of fixed logic thresholds there. 16-channel version, by the way, has 2 sets of logic thresholds. This one is fixed with a logic low of 0.8 volts and a logic high of anything over 2 volts. So, of course, that means it doesn't work on 1.8 volt systems. It may, just by sheer luck, but you know, you wouldn't count on it for any serious work. So really, it's only capable of being used on 2 volt, 2.5 volt, 3.3 and 5 volt systems. But of course, that pretty much covers, you know, every major system that you're going to work on. I mean, if you're working on 1.8 volt logic systems, you know, you're probably working on a pretty serious system, and you probably need a more serious logic analyzer anyway. And it looks like we have ourselves a low dropout 3.3 volt voltage regulator there. There's those input diode clamps. You can see them in standard 6-pin package there. It's got DL46 on. I'm not going to bother looking up the type, though. It'd be a low capacitive type. You can see the input series protection resistors there. So basically it goes directly from the input pins through series resistors, through the diode clamps, which are diode clamped to the positive and negative rails. You can do those with individual diodes, but it's just cheaper and easier in most cases to use these little packages. That's what they're designed for. They're cheap and popular, and of course that's duplicated over here. On this side, we've got our 4 resistors, another diode clamp. We've got our 24 megahertz crystal oscillator. We'll have a look at the microcontroller data sheet in a minute. It's a Cypress one, but that's about all she wrote. We've got ourselves a polyfuse there. Excellent, but well, that's all you need. And you can see we're up to revision 7 on the board. They've gone through quite a few revs on this little beast. This thing's been out for a couple of years, by the way, so I would have expected any kinks to be ironed out. And curiously, it looks like it's a 4-layer board. You can see that dark bit in there, the extra layer. So yeah, they've gone to the effort to go 4-layer internal ground and power. And the microcontroller is a Cypress CY7C 68013A-56. It's an 8051. Let's go to the data sheet. And here's the internal block diagram. The one we've got, of course, is the 56-pin SSOP package, as you saw, and it's an 8051 core operating up to 48 megahertz. And well, yeah, they're going to need that because it's 4 clocks per instruction cycles. So you've got to wonder, how are they getting that maximum sample rate of 24 megahertz when the 8051 core is only capable of 48 megahertz with 4 clocks per cycle? Because if you're using your GPIO down here, you just can't do it. It's not possible. But look down here, folks. There's a separate 4 kilobyte FIFO with its own data input down here. So clearly they must be using this FIFO, and if we dig further in the data sheet, which I haven't yet, we'll almost certainly find that that FIFO is capable of first in, first out buffer, by the way, so it does have buffering, and that, of course, is what they must be using for those higher sample rates. Otherwise, there's no way in hell that the program core running at that can read the GPIO and update the memory and do everything else at those sort of clock rates. It'd probably only be a few megahertz tops or something like that. So it's got to be using that FIFO. And I think if we traced the board, we'd probably find that those logic inputs go to the FIFO buffer. And I just checked further down in the datasheet, and sure enough, the inputs go directly to port B, which is down on the bottom side of the pins down here, and they're actually dual-purpose pins. They're GPIF, general purpose interface pins, but they're also FIFO data pins 0 through 7 as well. So it's almost certain that they're using the FIFO in there, but I also found out that the general purpose interface actually has a selectable interface clock of up to 48 megahertz. Awesome. So I'd have to read further into the datasheet whether or not they actually use the GPIF and there's some sort of shortcut down in the FIFO, although it doesn't show it in this block diagram. It shows that it has to go through the common address data bus into the RAM there. So whether or not that can actually sample through the GPIF into there at 48 megahertz rate, independent of the clock frequency over here, I don't know, but it's most likely that they're using the 4K FIFO there to buffer that data. I know I would. So one thing I'm curious to know, and I'm not sure if I'm actually going to be able to check this or whether or not it's obvious in the software, but is there any thing in the software that tells you that the latency is too high on your USB port and it's not able to get that data out at that clock rate? Is it smart enough to know that, oops, I've missed some data, we've got a buffer overrun and, all hell's breaking loose, and, well, it's not working at that maximum speed, because the last thing you want is data corruption or data dropping out through one of these USB, when effectively a real-time USB interface with just a little buffer in between to buffer the data. Because if you've got another USB device sort of, hogging the port or something like that, then, you don't want your data to drop out and your software not to know, because that would be a cardinal sin. You don't want that to happen, which is, of course, the advantage of a proper logic analyzer, like a real logic analyzer with its own internal sample buffer memory. But of course, that's a higher end, higher price, and it's got some limitations because, well, it's a limited buffer size. You can do buffer data compression and a real-time data compression into memory and stuff like that on some of the higher end logic analyzers. Even the lower end, some of the USB ones do that as well in a similar sort of price range. But this one, of course, has the advantage of unlimited memory, assuming that you stick within that data throughput rate. Now, of course, with the cables here, they have actually color-coded them, of course, and you might think, well, black goes to ground over here, but no, it doesn't. Black follows the color code, channel 0, 1, 2, 3, 4, blah, blah, blah. And they've actually labeled the ground lead there, the grey one, so that's how you're supposed to put it, not the other way around. It would have been nice if they labeled these ones as well with the channel numbers. And of course, we've got standard fare here on the little mini grabbers like that there, par for the course. You can buy them anywhere, dime a dozen if you lose them. Standard dual-sided pin like that, and you can just whack them in either side and go and probe. And by the way, one of the good things about these is that you can plug them directly into 0.1 inch headers like that. So by all means, if you've got room on your board and you know you're going to want to have to probe the thing, it's common practice just to build some 0.1 inch headers, add them to your board layout, just go into various signals you need to probe, and then you don't have to dick around with the mini grabbers like this, and they fall off if you bump them, and fiddly to try and get onto various pins directly on your chip. Much nicer if you use a 0.1 inch header, and you'll find that fairly common in a lot of commercial designs. So by all means do it. Make sure you add a ground point as well, and it can be useful to whack on some power in there for some external circuitry as well, just in case. Just a little tip. Wah, 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 wah. I was just pushing the ground thing in here, and it just pushed this apart like this. So yeah, folks, these aren't the best quality mini grabbers. Bummer, but they do work. But of course that's not broken, it just slips back on there. Not a problem. I know what you're thinking. You don't get much hardware for your $150, do you? Well, of course not, because with a logic analyzer, one of these USB logic analyzers, it's all about the software, folks, and that's what you're paying for good software. So let's put this thing back together, hook it up, and try it out. All right, we're on the website and let's download it. And look, it's got everything. It's got XP, Vista, and Windows 7, 32-bit, and Vista and 7 64-bit support. It's got Mac OS X, OS X, if you're into that sort of thing. Leopard, Leopard Plus, Tiger, I don't know. I'm not a Mac person. And it also supports Linux as well for all you Penguin fans out there, 32-bit and 64-bit. Let's download it. I'm going to use the Windows 7 version. And I won't bore you too much with the details of the installation, but let's see if it works. And is it quick? I don't know. Status bar, nothing. Come on. And it asks you to install their serial bus controller as well. It looks like they got their own driver for this thing, so yep, not a problem. I'm not going to always trust them. Launch the software. We're done, folks. And bingo! Oh, we're in. Too easy. Look at that. And of course, if we have a look up here, it's disconnected because we haven't plugged it in yet. So presumably, let me try that. And installing device driver software. A logic device was found, but there was a problem connecting to it. Another application may be using it. Looks like I've got to shut it down. Oops. Well, that was absolutely no dramas whatsoever. It just installed, didn't even tell me in the background, and bang, we're straight in, and there it is up the top, connected. Looks, there's options menu over here, which you can't see them all. Maybe if I can, I can't drag my capture window, but yeah, we've got preferences, display in ASCII. Oh, there we go, they pop up over here. So, save screenshots, save screen region, display in ASCII, binary decimal, hexadecimal, user's guide, and give feedback and report issues. This is the latest version. Let's have a look at the preferences. Pre-trigger, buffer size. Okay, excellent. That's what you want. You want some pre-trigger data as well. 10 meg samples, only 10 million samples, folks. If you're used to logic analyzers with built-in memory, then, well, 10 million is an absolute luxury. Enable longer captures up to 1 tera samples. Geez, that'll depend on data compression, I guess, as well, because it would, I presume it would do some data compression before it writes it to disk. And check for updates, animate zoom in, view state after new capture. What do we got here? Enable single click zoom. Aesthetics. Ooh, use aero glass style. Yes, no. There we go. Oh, look at that. That looks a bit better. Yeah, didn't like the other one. It was a bit wanky. So just when you thought this thing didn't have many options and preferences, and, you know, you're probably asking, oh, where do you set up all your serial data SPI? Well, you've just noticed this analyzer down here. Look at this. Plus, here it is, CAN bus DMX512. Brilliant. You don't get that very often. I2C. I2S, for you audio freaks out there, PCM stuff, the I2S audio. Standard Manchester one-wire bus for all you people working on one-wire, you know, Maxim Dallas one-wire and other one-wire stuff. Async serial, simple parallel, SPI, Uni I/O. All your basics are covered there with a few bonus extras. Although there is one that's missing there, and that's JTAG, of course, but JTAG usually quite high speed. Might have been out of the realm of something like this, but I guess it would have been nice to have JTAG in there, because a lot of logic analyzers will actually, you know, won't have JTAG. Even high-end ones won't have a JTAG option. And as far as measurements go, we've got width, period, duty cycle, frequency, show the byte, show timing markers, and show errors as well. Well, only one thing left to do, feed some data into this sucker and see what it does. Now, of course, I always like to try and use these things without reading the manual at all, because that's a true test of, you know, is this thing user-friendly or not? You know, if you're familiar with logic analyzers in general or some other bit of test gear, turn it on. Can I use it? Is it intuitive? Well, up here we've got our number of samples here, we've got our sample rate, and start. And I've hooked up an I2C bus to it, and I can just hit start here, and occasionally I'll get blank data because it is packet based. There we go, I get it a few times, blank data, and then occasionally I will capture the data. That's because no trigger is set up at all, and that's the first thing I noticed, well, where's the trigger capability on this thing? Like, how can I, trigger on a data packet or something like that? And, we've got some analyzers down here. Let's go I2C, analyzer settings. We can set it up. There we go. It looks like has it automatically detected? No, of course the clock is channel 0 up there, so we need to set that, and data is channel 1, so it hasn't automatically detected that. Address display 8-bit read write. I think I'm doing 8-bit read write, so let's save that. And it automatically labels them. Nice, that's another thing I was going to check. Rename them. Yep, beautiful. SCL, SDA, there it is. Oh, nice, there we go. And it's put the decoded data in there. Beautiful. Look at that. It's got the acknowledge in there and everything else. Nice. I like it. We're off to a good start, but I still don't know where the trigger is because we're just reading random data there, and we'd find it if we sample in. Hello? Come on. Where's my data? There we go. It eventually got a packet. And just scrolling around the data here, if I use the mouse wheel to scroll in and out, then that zooms and expands the data. That's exactly what I'd expect. Excellent. And then left button, I just hold it down and it automatically sort of, drags. It looks like it's got some sort of, buffering action on that pan stuff, but I just grab the left button and drag that left and right, and that sort of works. So let's go out like that, and there you go. You can see my multiple data packets there. And there it is. We actually need more samples than that. This is where the huge number of samples comes in as an advantage, folks. Let's go up to 10 meg samples, for example. Takes a while, but look at all those packets we can capture. Brilliant. Now, usually to get that, you either need a logic analyzer with a 10 meg sample buffer, or one with data compression that actually compresses the data real time so that it doesn't, during all these dead periods, one of those logic analyzers with data compression won't waste up, millions of samples storing just all one there. It'll go one during that time period, and it only needs to store a couple of bytes. So that's the advantage of those ones with data compression. This one, because it's real-time USB, it doesn't need any of that data compression. It doesn't store it on the device itself. But as you can see, we've captured a whole bunch of I2C packets. Nice. And if we have a look down here, we can actually open up new tabs as well as go into existing ones. It looks like it's got the 9th tab there, and then we can copy various stuff to the capture tab. Not sure what that's doing, but it looks pretty flexible. One thing I just noticed in that these data labels here haven't copied over to these tabs over here. Now, I'm not sure if that's a, and you can change the label on that too by the looks of it. I'm not sure if that's a feature for some reason or whether or not it's a small bug. Now, it looks like I found the trigger here. There's actually, for this, by the way, for the channel here, they've actually got, you can show and hide the various channels. You can move them up and down as well. You can't actually drag them, which, I would have expected to be able to grab that and just drag it around. But yeah, you can actually move it manually. I guess it's not too much of a drama. You only have to do that once, really, when you're setting up your logic analyzer to look and do exactly what you want. But in terms of, we can reset trigger here, but look, we've only got requires rising edge transition, and requires a logic 1 to be present when rising, and that's basically it. It doesn't look like, at the moment anyway, I haven't found it, that you can set up like a data packet trigger or anything like that. Now, one thing I really like are these auto cursors. As you can see, when I actually go in there, you can see that little timing cursor change, and you can see the data. Look, there's no data at the moment because I haven't actually moved my cursor over something. I don't even have to click on that, and it shows me the width, the period, the frequency, and the byte as well. Very, very nice. I like that. Now, I know it's grossly unfair to compare it to my Agilent InfiniVision mixed signal scope here, but that's what I've got it doing. I've got the scope actually generating one of these training signals, demo signals down here for the I2C bus. And of course, it's got, real-time decoding and hardware-based decoding as well. So this, this is a pretty good logic analyzer in that respect. Now, as you can see, there's actually some data changing inside this thing, as well as a bit of timing jitter as well, going back and forth, and that's obviously deliberate. And you can see all the data packets in there, and they do change like that in time period. And we're, of course, triggering off reference to one packet here. And, of course, that's what we're not doing at the moment with the Saleae logic unit. We're just, free triggering and just capturing whatever we get, whereas we want to actually be able to set a trigger point like that. I mean, any good logic analyzer should be able to set a trigger point for the data. So in effect, if we set a trigger point and we can't see the data changing, like for example, we'll go in here and you can see that the data's actually are counting up, 2468, 246, or 20, 40, 60, 80, stuff like that. So if we can't capture that on the Saleae logic, then, well, it's, not nearly as useful as a real hardware-based logic analyzer like this one. And of course, the other thing I like is the decoding of the I2C bus itself. Look, it tells you exactly what's going on there. It's setting up a write to address 226 with an acknowledge, and then the data byte is 16 with acknowledge. So, it's doing the business there. I really like that. But to actually check that this is accurate, I'm assuming it is, otherwise people would have reported issues and stuff like that, and if there were any, they would have been fixed. But for me to actually check that here, I need to ensure that that packet I'm looking at is exactly the same packet that I'm getting on my Agilent scope, and unless I can trigger on exactly the same packet, I'd have to go through and look at every one of them. Grrr. Well, I did relent and read the user's guide. It's not massive, but it is well written. And, well, no, folks, triggering is all you see there. Just, basic positive or negative edge triggering with data high or low, and that's it. There's no ability to trigger off a packet in real time, and that's rather disappointing. I don't know whether or not that's a horsepower issue to do with the PC to be able to process that data in real time. I wouldn't have thought so, especially, add the capability at some lower sample rates. Maybe you can't do it at 24 megahertz or something, but gee, I don't know, PCs are pretty powerful these days. I would have expected, so I'm quite disappointed that there is no trigger on data and stuff like that, or trigger on an I2C error, for example, so you could have it sitting there, just sampling away. So if you've got a data error on the bus you're trying to decode, and, well, you want to just capture the data and just have it sitting there in the background, and this data only occurs, once every hour. You want it just to sit there and wait for that trigger event. Look, I got an error on my I2C bus, and boom, it'll, capture the thing. But it really is a very bare bones interface. I do like it. It's nice, and the decoding is nice. But in terms of triggering and data analysis and stuff like that, it just doesn't really compare. So yeah, I mean, you're paying a bargain basement price for a logic analyzer, and you're getting quite usable software for the price. But yeah, don't expect professional league triggering performance and stuff like that. Look, there's no way that I can even search. Like, where's the search capability for actually finding this data, right? Confirm, restore. If I go over to I2C, I can export the data, save as text CVS. That's great. Okay, and but how can I find data? Let's say I want to find something where address 222 popped up or something. How do I do that? You can't, by the looks of it. And by the looks of it, I can't even real-time update this display. So let's say that I wanted to, trigger off the, rising edge here. And by the way, I can't even trigger off like a time period, like, oh, it's been high Like I can't even say, oh, it's been high for, X milliseconds or whatever, and then trigger on the first point after that. Can't even do that. Often called pulse width triggering. It just doesn't have that capability. But anyway, I would like a, I can capture the data, single shot capture, but where's like the free running mode where I can just, do that? Because then I'd be able to see if I was able to trigger off, for example, that pulse width. Oh, why does that spring back? That's really rather annoying. How that swings back, and it automatically swings back. Sometimes it does it, sometimes it doesn't. Don't know what's going on there. It could be a PEBCAC error, I don't know. But yeah, like if I was able to trigger off that first edge there after a time period, then I'd be able to just sit there watching this data packet refresh. But there doesn't seem to be a capability to do that auto sampling and auto triggering. Bummer. One good thing I like is it does seem to have fairly extensive data export functions. You can select which channels you want to export between specified times, so you don't have to export the whole lot. Binary, CSV and VCD. I don't know what VCD is off the top of my head, but there you go. It has all these different formats, and then you can, for the CSV stuff, you can do coma delimited, tab delimited, all that sort of stuff. Really quite flexible. I like it. So if you want to analyze your data in another package, looks like it's going to do the business. And another good thing, it looks like you can have multiple buses and decoding on at the same time. Like I'm trying to set up a asynchronous serial one, say RS-232 one at the moment, and of course it still has the I2C there, and it automatically, like if you go in here, set it up, it tells you that these two are already in use by the I2C. So looks like you can do multiple ones. Well, as you'd expect, because really it's only just, decoding this stuff in software after the fact. So really it should be able to do anything. If you can capture, so really you could, with 8 channels, you could capture 4 separate SPI, 4 separate I2C buses or asynchronous serial buses at the same time. Beautiful. But one annoying thing is I was on this tab here and I changed my labels and channels up here, but that only applied to that tab. So when I go back over here to this tab, they haven't changed. I don't know, is this a feature or not? Well, I'm looking at my RS-232 signal here, RX and TX, and it looks exactly like what I'm getting on my Agilent scope there. It looks so faithful, but it's telling me there's framing errors in there. So I've got this set to auto baud rate detection. So maybe that's not working very well, and I need to select a fixed baud rate. Let me try that. It had detected that the auto baud rate was 20,833. It's actually 19.2. So let's save that and try again. Here we go. Start. Boom. No, we've still got framing errors. Now, if we have a look at the data down here, we can zoom out on the scope as well, and you can see, let's look at this last transmit packet here, and you can see that the data is completely faithful, no problems at all there, but of course the data is incorrect. We're expecting 23 hex here and 31 hex, and we're just not getting that. So yeah, it captures it fine, but decoding, nah, for some reason, I don't know. And I'm just doing a quick SPI bus analysis and capture here, and it seems to be working just fine. Matches the Agilent, not a problem. It's just counting down. I'm just doing the output line here. I'm just capturing that. There's our clock signal up the top. There's our SPI enable, and there's our data. And this particular example I'm using is just counting down. And sure enough, it does count down. It's not counting down by 1, by the way, so that the data is correct. So not a problem. Actually, I think this tab-based business, I don't think that's a bug. I think it's specifically set up so that you can specifically save and capture that particular data that you were working on at that time. So that's why it doesn't auto-change the labels and stuff when you go between them. So I take back what I said about that. I think it's fine. So the verdict on the Saleae Logic 8 USB Logic Analyzer, $150 US or thereabouts. Well, it's pretty darn basic, as you saw. I was actually quite disappointed in the software, and if you want to check it out for yourself, you can just download the software freely from the website, of course. But it's very bare bones. It's nice. I like the way it operated, but geez, you know, there's no, as you saw, that I could find anyway, I stand to be corrected, no serial data triggering capability, no free running mode. It just, well, you know, geez, I expected more. This thing's been out for quite a few years, actually, so I expected them to keep adding features to the Logic Analyzer software, but I don't know what it was like a couple of years back when they first released it, but it's pretty darn basic, and I'm pretty disappointed. I expected more from that. So really, for $150, I don't know how it compares with the other USB Logic Analyzers out there. I haven't looked at them all, so I don't know. You're going to have to weigh it up yourself, but it's got to get a thumbs sideways at best, really. I don't mind it. The hardware's nice and rugged. The software seemed to work quite well for what it did, but very, very basic. And by the way, the 16-channel version of this, double the price. The Logic 16, you get faster speed on it, 100 megahertz for 2 channels, and then it drops for extra channels after that. So there's some extra hardware in there to do that, but the software is the same. So you pay that extra money and, well, you just get very basic software. It's okay for just, you know, general use, really. If you just want to muck around, capture your SPI or I2C buses, stuff like that, low speed stuff, it's okay value for $150, but just wish they'd add more features. Anyway, if you liked the review, please give it a big thumbs up. If you want to discuss it, jump on over to the EEVblog forum. Catch you next time.